Welcome to our video on the parts and functions of a hydrogen vehicle. Have you ever wondered what powers a hydrogen vehicle and how it differs from traditional gasoline cars? Well, in this video, we'll take a closer look at the different components that make up a hydrogen vehicle and how they work together to power the car. We will also discuss the benefits of hydrogen vehicles, such as their energy efficiency and environmental friendliness, as well as the problems that still need to be solved before they can be used widely. First, let's take a deeper look into the differences between hydrogen cars using electric motors and combustion engines. Both types of vehicles use hydrogen as fuel, but the way they convert that fuel into power is different. A hydrogen car using an electric motor is known as a fuel cell electric vehicle, also called FCEV. In this type of vehicle, hydrogen gas is fed into the fuel cell stack, where it undergoes a chemical reaction with oxygen from the air to produce electricity. There are a few types of fuel cell stacks, but the most common ones are proton exchange membrane and solid oxide fuel cells. Proton exchange membrane fuel cells are typically used in cars because they can start up quickly and operate at low temperatures. Solid oxide fuel cells, on the other hand, are better suited for stationary power generation because they require high temperatures to operate efficiently. The fuel cell stack consists of multiple fuel cells which are stacked together to increase the amount of electricity produced. Each fuel cell contains an anode, a cathode, and an electrolyte, and when hydrogen gas is introduced to the anode and oxygen is introduced to the cathode, a chemical reaction occurs, producing electricity. The electricity powers an electric motor that drives the car's wheels, with water being the only byproduct of the reaction. A hydrogen car using a combustion engine is called a hydrogen internal combustion engine vehicle. In this type of vehicle, hydrogen gas is fed into an engine, where it is mixed with air and ignited. The resulting explosion drives a piston, which turns a crankshaft and powers the car's wheels. However, hydrogen internal combustion engines emit pollutants such as nitrogen oxides and particulate matter, similar to gasoline-powered engines. However, fuel cell electric vehicles have an efficiency of 60%, which is 2 times higher than the efficiency of the combustion version. This means that fuel cell EVs require less hydrogen to travel the same distance, making them more cost-effective in the long run. Another important part of the FCEV is the electric motor. This is what converts the electricity produced by the fuel cell stack into mechanical energy that moves the car. There are 2 main types of electric motors used in fuel cell vehicles: the AC synchronous motor and the DC brushless motor. The main difference between these 2 types of motors is in the way they operate. The AC synchronous motor uses a set of magnets to create a rotating magnetic field that interacts with a set of coils to generate torque and turn the motor. The DC brushless motor, on the other hand, uses electronic commutation to switch the direction of the magnetic field and keep the motor turning. This makes the DC brushless motor more efficient than the AC synchronous motor, but also more complex to design and manufacture. Next, we have the hydrogen storage tank. There are 2 main types of hydrogen storage tanks: compressed gas tanks and cryogenic liquid tanks. Compressed gas tanks are made of high-strength materials and are pressurized to store the hydrogen gas. Cryogenic liquid tanks, on the other hand, store hydrogen as a liquid at extremely low temperatures. Further components of a hydrogen vehicle are the power electronics, which manage the flow of electricity between the fuel cell stack and the electric motor. These electronics include inverters, converters, and other devices that control the voltage and current to ensure that the electric motor receives the right amount of power to operate efficiently. In addition, there is a cooling system that helps regulate the temperature of the fuel cell stack and other components. The cooling system uses a combination of air and water to maintain a safe operating temperature and prevent overheating. Hydrogen vehicles also have a battery pack, which is used to store excess energy produced by the fuel cell stack. This excess energy can be used to power the electric motor during periods of high demand or to start the car in cold weather when the fuel cell stack may need additional time to warm up. Finally, the hydrogen vehicle has a number of safety features, including pressure relief devices and sensors that detect leaks or other potential hazards. Now let's take a closer look at how the different parts of the hydrogen vehicle work together to power the car. When the driver presses the accelerator pedal, the hydrogen gas is released from the tank and flows through a regulator valve, which controls the amount of hydrogen that is supplied to the fuel cell stack. In the fuel cell stack, the hydrogen gas is combined with oxygen from the air to produce electricity through a chemical reaction. The chemical reaction occurs at the anode of the fuel cell, where hydrogen molecules are split into positively charged hydrogen ions and negatively charged electrons. The electricity generated from this chemical reaction is then sent to the electric motor, which converts the electricity into mechanical energy that powers the car's wheels. As the car moves, the only emission produced by the FCEV, as we said before, is water vapor, which is released from the tailpipe. This means that hydrogen-powered cars are not only more energy efficient and environmentally friendly than traditional gasoline cars, but they are also much quieter and produce less vibration. One of the main concerns about hydrogen-powered vehicles is the cost of hydrogen fuel. Currently, producing hydrogen is more expensive than producing gasoline or diesel fuel. However, the cost of hydrogen is expected to decrease as more production facilities are built and economies of scale are achieved. There are also three types of hydrogen, which can affect the cost. Green hydrogen is produced using renewable energy sources, such as solar power, and is considered the most environmentally friendly choice. Blue hydrogen is produced using fossil fuels, but the carbon emissions are captured and stored, making it a cleaner alternative. Gray hydrogen is produced from natural gas through a process called steam methane reforming, which results in carbon dioxide emissions being released into the atmosphere. It is currently the most common method of hydrogen production and is also less expensive than green hydrogen. In conclusion, hydrogen vehicles are a promising alternative to traditional gasoline-powered cars. The fuel cell stack, hydrogen storage tank, and electric motor work together to produce an energy-efficient and environmentally friendly mode of transportation. However, as we continue to move towards more sustainable and eco-friendly forms of transportation, hydrogen vehicles present a promising alternative that can help reduce our carbon footprint and create a more sustainable future. We really appreciate your support of our channel and thank you for taking the time to watch our videos. If you enjoyed this content, please show your support by leaving us a like, sharing the video, and subscribing to our channel. Don't forget to ring the bell to stay up to date with all the latest developments in EVs and green technology. Once again, thank you for your support, and we hope to see you again soon.